Hello, everyone, and welcome to today's edition of our Tech Talk. So today we have a very exciting topic as we will be covering Delegate Access Control, which is a privileged access management for Oracle services and support the staff. So again, my name is Leo Alvarado. I'm from the product management team uh, for database cloud services. So we take care of Exadata database service, base database service, and also multi-cloud. And for my co-host, so we are very lucky to have him today, and I'm very thrilled to introduce our guest, Mr. Jeffrey Wright. So he's a key member of the product management team behind security, networking, and management, who has worked on some of the most innovative and coolest features that we will be talking about today, which is delegate and access control with database cloud services. So hi Jeff. So thank you for joining us today, and welcome to our Tech Talk.
Yeah, thank you, Leon. Thanks for the nice introduction.
Okay. And then for today's session, we have prepared a jump-packed agenda. So we'll be covering all these learning points. So we'll start first with the when and why. Like we will learn like when and why you should use delegate access control, and then we'll go to learn more about data problems and Oracle solution. And then we will learn about the what, like we'll learn about what is delegate access control, and then we'll move to the how, like learn about how delegate access control works, how to implement and use delegate access control with database cloud services. And since I mentioned about database cloud services, so I'll start with Exadata database service. So did you know that the Exadata database service provides choice of multiple deployment models to suit your business and workload requirements? So yeah, so that's one of the greatest differentiators of Exadata. Like Exadata runs everywhere. Like you can run it on premises, uh, where you own and manage the complete system and have the total flexibility as how you will manage it. Or you can also run it in a cloud where Oracle manages the infrastructure and you have the automation to simplify your management task, and that you can leverage on a pay-per-use subscription model that can help dramatically reduce your cost. And Oracle offers Exadata in the public cloud with Exadata Cloud Infrastructure and with Exadata Cloud at Customer. So you can benefit from the same cloud deployment, but you can keep your data inside your own data center. And Exadata is also available with multi-cloud, where you can have your databases run on Exadata in Oracle Cloud, and an application run on other clouds. Like for multi-cloud, so we have of course the Oracle database in Oracle Cloud Infrastructure. We have offerings for Oracle database at Azure, Oracle database at Google Cloud, and Oracle database at AWS. And this is just a quick summary of some of the enterprise capabilities you will get with Exadata Cloud. So on the left are all the key features available in Oracle database. So that includes your important features like multi-tenant, Oracle Real Application Clusters or Oracle RAC, and Active Data Guard. And on the right, you'll see all the Exadata innovations available with the Exadata platform. So including the recent additions like the AI Smart Scan. So Exadata Cloud includes all these key capabilities and innovations in a single cloud platform. And since we'll be talking about management, so with Exadata Database Service, it follows a simple cloud management model. Like Oracle owns and manages the infrastructure. This includes the database servers, the VM host, storage servers, and the Fabric network. But you can schedule the maintenance windows for Oracle to perform the infrastructure maintenance. Now, when you subscribe to the Exadata database service. So you are responsible for managing everything running in the database VMs. So you manage the VMs, the grid infrastructure, the databases, using cloud automation tools. So the powerful cloud automation gives you complete control over the components that you manage. And finally, of course, you own everything inside the database. So this includes your data, your schema, and encryption keys. And it is very simple to utilize the OCI Web Console to manage your Oracle Database Cloud Services. Like you can use the navigation menu in the upper left corner to navigate to the database service pages where you can create, manage, and view your cloud database resources. So for example, the Exadata database service can be managed from the web console by first selecting Oracle Database in the navigation menu. And you can then select either the Exadata on Oracle Public Cloud, which is Oracle Exadata Database Service on dedicated infrastructure, or the Exadata Cloud Customer, which is Exadata Database Service on Cloud Customer section, so that you can go to the respective admin pages. And OCI or Oracle Cloud Infrastructure provides a wide choice of management interfaces that can be used with your database cloud services and also with Exadata database service. So the easiest to use is the web browser interface, which allows you to use browser to graphically configure the and to initiate operations. And this is great for one-time actions. But if you also prefer to do more like a programmatic interface for things done repeatedly, such as provisioning or updating databases, so anything you can do with the browser, you can also do with a corresponding REST API. And all interfaces are also exposed by a command line interface, which we call OCI CLI, that can be used for scripting and for building custom tooling. And there's also an SDK or a software development kit to integrate with to integrate it with common languages such as Java, Python, Ruby, and Go. And if you prefer to manage your infrastructure as code, there's also a Terraform and Ansible interface. So the cloud automation that we provide, so it simplifies most of the life cycle and management tasks. So including uh, adding additional servers, scaling OCPUs up and down, creating databases and database homes, scheduling infrastructure maintenance, updating and upgrading the VM operating system, grid infrastructure, and databases. What else? Performing backup and recovery operations, and even enabling disaster recovery protection through data guard association. So again, this is just a sampling of the automation from our whole list. And as we mentioned about cloud automation and management, so there's also another interface for management, which did you know that the Delegate Access Control provides privilege access management for Oracle services and support staff, which will be my cue to hand it over to my co-host, Mr. Jeffrey Wright, for our main topic today, which is Delegate Access Control. So over to you,
Yeah.
Jeff. Let me just unshare and right.
Yeah. Yeah, and thank you for the introduction, Leo. Thanks for the folks that are out here joining. I'll walk through and go through the slides. And as technical talk, I think, Leo, if we bring up the interfaces at the end, if we have time, that's all in scope, right?
Yep.
So so yeah, and please, Leo and I work together. If you have questions, raise a hand. Do we do interactive stuff with Ask Tom? Like if someone stops me, there's not a lot of people here.
Yeah. Feel
But
free
if
to.
yeah, if you have a question, ask me. I mean, the folks that know me know I like to talk more than I probably should like to talk. Guess I'm a Sag. All right, let's get started. So, delegate access controls privilege access management for Oracle services and support staff. And what we're really talking about, as Leo said in the agenda, we're talking about when and why you use this, some of the problems behind it. The motivation here is I'd like you to understand that this is a first-class privilege access management solution. Y'all might be familiar with things like CyberArk and things like that. And so, yeah, I'm trying to integrate that into the system. And when you go through those pieces, my hope is that you come away seeing that you can approve this. If you took it to your security team, I might be the person who talks with your security team, and at the end of it, it's a good service. And then we want to show how it works because it's going to integrate your work with Oracle people, just like we're integrated with technology. And finally, how to implement it. And provided we have time, we'll actually do some real work with it. So first, when and why you should use this. Not stated here, but this is a technology that's today shipping for Oracle staff. So first, if you ever need an Oracle person to help you in your VM. So if you open an SR, you're a developer, you're a database administrator, you're working, and there's something that you don't know how to do or something that seems amiss, and you open an SR, you'll get a response from the Oracle support people. It might be upload the logs, it might be set up a shared session so that we can figure this out. Delegate access control first is a mechanism for you to control those Oracle people when they access your system. Your security team might tell you that you have to minimize the time that people have access to the systems, the number of people that have access to systems, and enforce minimum privileges. So when you use delegate access control, if an Oracle person asks, that's the person who will get a credential. And we have controls in place to prevent that credential from being stolen or used by other people. The amount of time is just temporary. You're granting access for a short period of time, and you control when that time ends. The software will automatically revoke it and it ends. And when the Oracle person is done, they can end the session too. Enforcing minimum privileged access is done uniquely by Oracle using Oracle Linux root jails that are engineered end to end into the Exadata. So just like we have Oracle database processing that's faster and optimized than the Exadata because the storage servers understand the ASM reason code for the I/O. Oracle knows the data. That makes it so we can write clever software to make the Exadata fast. We understand how the clustering works. We can write clever software that have fast node depth detection, and we can do things in the infrastructure with our DMA that would be difficult to do if you weren't an Exadata. And we've extended that same idea to the security. So when you're looking at the security and the access controls, we want to make granting access fast and straightforward when it needs to be done. We want to control it in a way that we all can understand. And then finally, at the end of it, we want to prove that we've done what we've said we did. So as an Oracle support person, I'm here to do a great job. And an important part of my work is I'm proud enough of it that I want to show you commands and keystrokes what I've done. And the nice thing with that, pride and attention to our work is that we've built a very good, easy to use interface so that after you've had an Oracle person help you out, you'll see a full records of the commands and keystrokes. You can learn from our Oracle person so that you don't have to call them again. And you can also prove to the people in your organization that the Oracle person did what we said we did, and the audit record will help you to show that we've done no more. The implementation is designed to simplify configuration, operation, and audit. We often, get excited to, set something up, which is straightforward. We have great automation around configuration, but sometimes we forget about operation. Like, how do we integrate your people and Oracle people together? And we're building cloud interfaces to help us integrate people across tenancies, integrate people across identity spaces, integrate the people in different companies so we can work together. And then when we do the work, sometimes we forget about audit. We'll talk a little bit about the Oracle Linux audit service. It's easy to hand wave and say this service is great. It's an industry standard. But anyone who sat down with the man pages for the AU report or looked at the actual audit records, like, it takes a lot of skill to understand these things. So what we built is automation to help summarize what's happening in a way that makes sense if you need to understand what happened, and a way for a human to understand what that is. And so what we're talking about doing is reducing deployment time with the automation and improving this operational efficiency to help us remove questions about what's going on. And what you're going to get out of this is the value of Oracle as a service provider. Again, we write great software. We're excited that you like to use our software, and we're building this so that our great people can come work with you, so that you can realize these unique financial, operational, security benefits of an integrated cloud service from Oracle. And compare that to just like spinning up some piece of bare metal compute. I mean, you could do all this work yourself, but we as Oracle want to tie this together for you, but with our great technology and great people. So we take a step back. What is this problem with computers, right? We put all this important information in computers, and of course, people will find other ways to use that information. And in some cases, there are people that do things that we might not want done. So we sometimes refer to those as breaches. Verizon publishes a report every year. The links on the slides will take you directly to that report in the executive summary. And we've pulled some pieces from that report to show you important things that actually go wrong in the real world, and then help you match that up with delegate access control so that you can see that this software is explicitly designed with the requirements to fix the most important, most commonly occurring breaches that are listed in this Verizon report. In a lot of ways, I'm trying to help you here show that it's not me that you have to believe, it's not Oracle that you have to believe, but you can go line by line with the report, you can go line by line with the tech and help people that need to approve this understand that we built the tech to solve real world problems. 68% of breaches, according to the report, happened by people. So we as people still do things that maybe we're not supposed to do. Delegate access control enforces a separation of duties to help prevent a single person from acting without the approval of a second or third, and provides the audit to further separated staff. So, you like us, we're all in the business of doing a great job. And what we want to do is make it so that our great job gets done in the bright light of day at the approval of the people that are around us. So we all know we're doing the right job. Almost a third, 31% of the breaches over the last 10 years use stolen credentials. I mean, anybody who's ever generated an SSH key pair and has this private key that's sitting, you use to authenticate to a system with SSH, and I've seen it happen. I've done it. You send the private key to someone else, and that means two people now can log into the same account with the same credential. When that happens, you lose track of what's going on, and before you know it, somebody gets a hold of that credential. Hardly a day goes by where you don't hear about somebody's password showing up on the dark web. To prevent stolen credentials from happening, Delegate Access Control implements a user-specific credential that's temporary and authenticated via FIPS 140-2 Level 3 hardware multi-factor to help prevent credential theft. At a high-level picture, I have a device plugged into the side of my computer. It's a YubiKey. In order to authenticate to one of these accounts, you have to physically have the YubiKey, and you have to know the passcode. So not only is stealing the credential hard, but stealing it at scale is very difficult. You can't publish YubiKeys on the dark web and then start shipping them to all the thieves you want, right? It's much more expensive. A third of the breaches are ransomware, right? You hear all these stories about ransomware. Hackers know that all they need to do is gain privileged access to a system, run, a very easy to gain access to encryption algorithm, sneak in their own encryption key. Before you know it, they've encrypted your data. They didn't even have to steal it. They just need to make it inaccessible until you pay them. Delegate access control further enforces privilege limits to help reduce where ransomware can reach. So that if you have an Oracle person helping you through delegate access control, one of the things you'll see is most of the time we don't need to use root access. What that means is we can fence off sensitive parts of the system, including things like database data files and wallet files and things like that, so that if somebody were to deliver ransomware, the temporary account doesn't have a reach to cause as much damage, limits this blast radius, so to speak. Some 28% of breaches are errors, right? We are people, we do the best job we can, but we don't always have all the information, and sometimes we make mistakes. Delegate access control will enforce a separation of duties to help prevent a single person from causing a mistake. And when we look at this, the idea is we start with the ticket that's generated by a ticketing system. If you have opened an SR asking for Oracle's help, that generates a JIRA ticket on the back end. From that JIRA ticket, we will open an access request. You'll see your JIRA ticket in the access request. In the ticket, you put in your system name, right? Maybe you got it right, maybe you made a mistake. When we ask for access, we'll read the ticket, we'll ask for access to that system. You can check that this really is the right system and you can approve it. Or if there's been a mistake, we have places along the line that can help catch that. And finally, 15% of the breaches involve a third party. So you might have a partner and your partner needs to access your system. And, I know none of us would ever do this, but stuff like this happens. Maybe you give a third party person an SSH private key. Maybe you give a third party person a password to a service account. Maybe you have the intention to like change that password or whatever right away. But you also have to use third parties, like especially with the Oracle. Like we're here to help. You need us to do work because we're really good at what we do. A house cleaning company, we like specialize in house cleaning. We really want to do this infrastructure work really well for you. And you might partner with other people. And in order to keep those third parties safe, you have to have a good way to manage them. So what Delegate Access Control does is allows you to control when Oracle, as a third party, can access your system, enforces privilege limits during access, and provides a machine readable and human readable audit record. Handful of best practices. We'll not go through a ton of the details here. You've probably all heard about these, but if you go to, your favorite privilege access management provider, ask somebody like CyberArk, what are the industry best practices? If you're me, you work with a bunch of banks and they tell you what those are. Session isolation monitoring and recording. This enforces session isolation with unique temporary user-specific credentials to isolate sessions. Oracle and Exadata provides command and keystroke logging. We stream the logs in syslog format to your syslog server. We could send those logs to any SIEM system that you have, provided your SIEM system is compatible with the Oracle Linux implementation on our Exadata service. Multi-factor authentication, we all hear it. We get our phones and all these different things that we use. We've got that built in. The authentication mechanism is MFA, FIPS 140-2 level 3. A very easy answer to that question. Some people will say just-in-time access, zero standing privileges. That's exactly what this does. There is no credential for Oracle in the design or in the software unless we've asked for access and you've approved it. We'll generate a temporary unique credential in response to OCI IAM authorization and deploy that credential for use. And then when we're done, we remove it. The software will automatically remove it. The Oracle operator can remove it, and you, of course, can remove it. There are no third-party agents, no additional VPNs that are required. We don't have to have an Oracle person shelling through your VPNs. We don't have passwords in the system. We use hardware multi-factor authentication that's built in with the pass code that's for the hardware device. And even better, you don't have to add a user to a directory service. So for Delegate Access Control, we have a tunneled SSH implementation that's implemented through an OCI public cloud endpoint. So OCI manages the entire network, temporary bastion server, temporary network end-to-end. We manage the users for the service provider. So what you've said is, Oracle, you have a staff of support people. If you're in the support organization, you know what you're doing. Oracle takes care of vetting the support people, making sure that the support people know what they're doing. I mean, as the end user, you probably don't know enough to make a good decision, but Oracle does. And by our Oracle internal tools, our HR system is integrated with our identity management system so that our users that are working in the support organization can ask for access. But outside of that, the software will prevent them. And then if our user moves outside of the support organization, their credentials to ask are automatically revoked. Their credentials to use the service are automatically revoked. The affinity of the human identity for SSH to the API identity we use in OCI is using the hardware multi-factor device. And this is an important nuance. SSH is authenticated differently than OCI IAM. You have SAML or whatever for OCI IAM. There are lots of identities that I will use, but to tie all these identities back to me, I register my hardware multi-factor device with each of these systems. So it's the hardware multi-factor device that is what I use to prove who I say I am. And it's the integration of that hardware multi-factor device and these various different identity managements that authorizes me to do work. The finesse or the nuance with this hardware device is I use the device to authenticate to OCI for APIs that has all kinds of, Oracle HR Federation kind of stuff. It also has a private key for SSH, so I use that same device to SSH in. And this is a very clever way to remove the problem of adding users to directory services, managing directory services, interoperating directory services. We even remove the need to have a network connection out to a directory service, which makes the system have a smaller attack surface. And then finally, when you ask who can get a credential deployed, the hardware or the software rather enforces the users that can ask by the service providers, group membership. And of course, we at Oracle integrate that into our HR system. So we don't have the gap when a person changes jobs, a person gets promoted, or a person, goes to a different company. So back to why you use it, you control Oracle. We want to be controlled by you so that we can do work on systems safely and when it's needed. That means you control the time, the number of staff, and the privileges. Those are all built into the system. Software does the enforcement. We want computers to know, we want to take the rules, we want to program the computers to enforce the rule. And those enforcements include non-interactive remote API and predefined shell commands. Sometimes we just need the audit logs. We can run that without even interacting with a shell. So we built these privileges into the system to make some things that are simple and easy to be safer. We need an interactive shell. We can do a lot without root. Again, we enforce that with Oracle Linux to root jails, an open source technology that we all can learn and understand. And sometimes we need root. I mean, that is true. When root shell access is necessary, we will ask for it. It will happen in the design after you've approved it, and it happens via su or sudo after named user login. So we try to get into root as safely as we can, and we want to make that root use traceable to the person doing that. Just like your surgeon might, do a procedure and you have a, anesthesiologist that puts you under general. We have cameras, for observation, right? The doc does the work. We're really proud of the work we do. And even though the doc could do more, that's not our intent. We don't make money like that. And so we have this audit log that shows everything that we did. We have the named user, so you know who was there. So we try to keep this as safe as we can. And of course, with root, sometimes that's the only way to resolve an issue. So what we're saying here, positioning, is that when we have to use elevated privileges, we want to do that in a way that we can make as safe as possible so you can realize the benefit of getting a resolution that required elevated privileges. Back to how this works, you observe keystrokes and commands run by Oracle staff, gold standard for how things work. It is worth noting that if I were to shell in through a third-party PAM product, right, you could see the commands that I run, and maybe that third-party PAM product is smart enough to go see the shell that runs after, and maybe it does it through Oracle Linux Audit Service. We're bypassing all that extra wrapping. We're just using the Oracle Linux Audit Service. And so when you use this system, you get the TTY records for the audit service, that's the keystrokes. And then all the commands that run are recorded by Oracle Linux and boiled up to you. So if somebody were to alias a command to something that you didn't expect, you change, a command like cat to do something else, you can see that in the Oracle Linux Audit Service. And again, your SIEM folks will be happy. We can forward the audit records to any syslog server. If it's compatible with Oracle Linux and the Oracle Linux Audit Service, your SIEM system can probably pick it up directly. So kind of stepping back, what are the benefits, right? The unique temporary credentials for each work request protects personal information. So we don't have to know your personal information. You don't have to know our personal information. It's all obfuscated so that we can work safely. And that helps us when we work in different countries. Not every country has the same HR laws. It also helps us prevent collusion. We're eliminating direct access to service accounts. Part of my lot in life is the exposure of service accounts leads to abuses, and we want to make it so that we just don't ever access these directly. The software gives us a mechanism to eliminate that direct access. Likewise, shared authentication secrets. In order for this to work, you have to create an OCI service, or we create a service. Our service has a group. We register everybody in the bright light of day, which is our HR process. And then the authentication secrets, that hardware multi-factor device. That helps to prevent sharing secrets. The best access is no access, right? And so if the safest system is turned off, but it's not very useful, the next safest system is one running authorized software that doesn't allow people to log in. So what we do is add an isolation control, which is to not have a network in place. We do that with Bastion servers. We implement a temporary network when we need access. And of course, since we do it with OCI APIs, that temporary network is created in a way that's logged by the OCI audit service, and it's governed by OCI IAM privileges. We directly tunnel SSH from the end user device, that's the laptop, to the target device. That helps us prevent a man-in-the-middle attack. So, people, I love the security person who says, I don't trust you, so I want to open up your sessions so that I can see everything that's going on. And of course, my response is, well, I don't trust you as a security person. How do I know you're not going to hijack my system session and do something that I didn't intend? When you stop at a jump box, you're logged into the jump box, you are at the whims of that jump server. You don't know what the person in that jump server is going to do. If you happen to type a password at the command line, you just shared the password with the jump server. Like, it opens up an attack surface that we don't need. What we do here is directly shell with hardware multi-factor authentication from the laptop to the target using a tunneled SSH implementation to eliminate man-in-the-middle attacks. Or prevent man-in-the-middle attacks, we should say. Once we land, you got to control the endpoint. The way we land at the endpoint to control it is to use this unique Oracle Linux root jail. And just like the Exadata team designs the system to eliminate IOs and designs the system to optimize the way we process data, we've now designed, engineered, and tested this to enforce privilege limits. That means you're benefiting from Oracle engineering that built the Oracle database service. The team that built that software knows which parts of the system is sensitive. Also, what parts of the system need to be accessed when we do work. Again, turning the system off or blocking all access prevents us from realizing value. We have to allow access to the system. If you built your own system, it's up to you to determine where all the sensitive stuff is, and it's up to you to protect the system. When you work with Oracle, it's Oracle that knows all of that stuff. We've been writing the software for decades. Our engineering team tests, reviews, design, we build this, and we do it at scale for all of our cloud customers. So that when you think about why you want to use this feature, it's because the same reason that you like Exadata, which is all of the integration, we've now built that into the security and the access method. Just like fastest IO is the IO you didn't have to do. We talk about that with Exadata. The most secure shell access is the shell that you didn't need to do. We built it so we can remove a bunch of shell access. So remote diagnostics that we can do by API, we can just ask you to run an API. If we need to run a sequence of commands to do something, we can ask you to run a sequence of commands. Those run in a temporary account in a root jail, just like we're talking, but it's run by an interpreter rather than interactive shell. Then, of course, our goal here is to reduce root to the bare minimum of only when we need it, to make sure we only get this after we've asked you and you've approved. So to get this all to work, we separated out entitlements, enforcement, and audit. And for people that studied math, right, you have different coordinate systems that are handy for different things. You think about X, Y, Z Cartesian coordinates; those are great when you have squares and rectangles. And then you have polar coordinates, right? Those are great when things are in cylinders and spheres, and spherical coordinates when you have like spherical stuff. So it's handy to talk about this kind of access management using entitlements, enforcement, and audit. The first piece is we manage entitlements through OCI interface, and we control that with OCI Identity and Access Management, or IAM. So this is all about what systems can be accessed, who's allowed to access those systems, and what privileges that they can ask for when accessing a system. The next step is to enforce it. So once we've said things are allowed to be done, how do we make sure to use, or how do we use software to make it so that you can do the things that you've been entitled to do, but we prevent you from reaching beyond that? So the first way we do it is that Oracle Linux Chroot jail, as we described. That's the enforcement mechanism for the minimum privileges. The entitlement to access the system is enforced through temporary network access that's built using just-in-time Bastion servers and VCNs, cloud technology that you probably know about today already. And then how do we enforce that, I'm allowed to do work when you've let me do work and, Leo's not allowed to do work, or vice versa? We enforce that to use SSH that is authenticated to that FIPS 140-2 level 3 hardware MFA standard. Now we get to work, right? You have to ask the question of how do we want to audit this system? So there's lots of ways you could do audit. You can buy third-party products that will do audit for you. What we as Oracle have decided is that we're going to audit through the standard and proven Oracle Linux security features that are integrated with these OCI services and your services already. So just like we enforce with an open source standard technology, we audit through that same style of open source standard technologies. And what does that mean? It's Oracle Linux Audit D command and keystroke logging for all of our access. We can integrate this with OCI logging service, your syslog server, things that you already use today. And we've put together a clever human readable interface for command and keystroke records. And of course, the OCI audit service logs all the lifecycle management, which is what we do with the entitlements. We tried to build this in a way that's easy to understand and hopefully easy to approve, or at least straightforward. This picture, just a quick glance at how the block diagram works. Some service provider, shown here in green, registers a service. You as the customer, shown here in red, subscribe to services, and then the blue software Delegate Access Control takes care of that orchestration. It is important to note that we have security checks and reviews and oversight and separation of duties through all these different pieces. I want to build a service, I've got to register that with OCI. We have a catalog where you can have oversight people that pay attention to this. And then we do all of the orchestration and work using these cloud APIs to make it not just quick and easy to do, but also to have a good audit log. Today, there's 4 different providers. Oracle Database Cloud Customer Support. So these are, if you open an SR and you need an Oracle Database Support person, the Oracle Database Cloud Customer Support, if you subscribe to that service, means that Oracle person, rather than posting in the SR, hey, can you upload the logs, grant me access, start a Zoom session, all of those things that make support, add friction to support. What that support person can do is click an interface and ask for access to a system. That'll show up in your OCI tenancy as an access request. You could get an email notification, SMS, or pager. When you say yes, our Oracle person gets to do work. This is included in your CPU subscription. There is no additional cost. Oracle Database Cloud Operation is the operations team that manage the Exadata. So sometimes there's an exception in your virtual machine that requires the operations team to access the virtual machine. When you subscribe to this service, when the SR rolls down the collab SR to the operations team needs to do work. Instead of the operations team updating the collab SR, the support team updating the regular support SR, and you getting this note that says, go do something, upload a log, whatever. In this case, the operations team asks for access, just like the support team could ask for access. You grant their access, and the operations team can do their work. Our Oracle Engineered Systems Deployment and Infrastructure Support. This is our ESDIS service. It's from our Customer Success Services team, similar to what you might remember if you use Platinum Support Services. If you want to get that team to help you out, we do all kinds of business from patching to performance tuning to run and maintain. If you subscribe to this service, you will tie it to a specifically noted contract for a specific part number, specific SKU, and you can enlist Oracle support services. And rather than onboard them into your HR systems and go through all that work to set up virtual machines for jump servers and all that kind of stuff, they will ask for access using this same method. And then finally, our strategic customer program, our white glove services for folks that need special treatment. this program for those kinds of customers with exceptional use cases are negotiated separately from the OCPU subscription. So rather than come in as root all the time, we've got 6 levels of privileges listed here, from what we'll argue as the safest to the highest risk access. API access just lets us run an API. So if we needed to do a patch pre-check, we can say, just let us run the patch pre-check API. If you do this, we run the same OCI API that you would do to do a patch pre-check. And we can do it from an operations perspective or support perspective. Log access, that's how we pull the logs from your system. So today you can subscribe to an automated log monitoring. That's 24/7, 365. Something goes wrong, it uploads the logs. If you need to control those logs so that they're only uploaded after you've authorized to do it, we can use that log access thing to gain access to the remotely connect the logs after we've asked and you've approved. Virtual machine command access, that's a mechanism where I, as the operator, need to run a half a dozen operating system commands. I put those operating system commands in a JSON document, upload that JSON document to the access request. That JSON document indicates the commands I need to run. You can say, great, you can run this batch of commands. And then I submit that batch of commands to be run on the virtual machine. It's still running the root jail. It's still running the temporary account, so you can see the record of the commands that I ran, but it's just commands. I can't shell in. So that's a nice way to make it safe to just do a batch thing. Diagnostics, that's my real-time interactive shell. With that interactive shell, I have the capacity to do things that software wasn't pre-programmed to do. That's really handy when the existing diagnostics aren't quite enough and we just need to do some work. Diagnostic prevents access to sensitive information, system configuration changes, restarts, and access to the audit system. Virtual machine system maintenance, this is how we do real work for a good number of cases. We can gain SSH access to the VM clusters with limited privileges. The software prevents access to the root account. It prevents tampering with the audit system. And it allows us to do work like change software. It allows us to restart the system, and it allows us to do the work that's required to resolve an issue. Full access, that's where we can SU to root. And so sometimes when we really got to solve a problem, we have to SU to root. If we ask for full access, we'll first land as a operator named user. We land as that named user, and as root, we can do whatever it is that's necessary and access the arbitrary files and directories, devices, and implement any change that we need so that we can get you up and running quickly in a corner case where we've had a failure that requires this kind of access. From a workflow, what we want to do from Oracle's perspective is prevent things from happening unless they're supposed to happen. And if it's supposed to happen, we want to make it happen quick and easily. So the way that we do this is we use OCI IAM policy to describe what's allowed to happen, and OCI IAM authentication to make sure the people are making the right decision, and the OCI IAM authorizations make sure that the right people get to do the right things on the right systems. So when we integrate it all together, there's a ticketing system. So you open an SR, generates a ticket. That ticket gets picked up by an operator. Our operator uses an OCI API to make an access request. The software checks to make sure that the ticket is not being used by any other access requests. I mean, these kind of little things help to prevent someone from doing something that they shouldn't be doing. That cross-tenancy access is how we get real work done. In your tenancy, you see that access request. You don't know the personal information of the operator. The operator doesn't know your personal information. Software prevents that. When you approve the access request, it starts that software orchestration to deploy. That makes that temporary credential in that root jail. Once that credential to root jail are built, we'll orchestrate that temporary bastion server, temporary network connection. Once that's in place, our operator shells in, does the work. The audit records get streamed to wherever you configure them to go. So you can forward them to a syslog server, you can forward them to OCI logging service, you can forward them to your SIEM using technology that's compatible with the Oracle Linux operating system deployed on Exadata. couple pictures of how this implementation happens. We as Oracle maintain minimum privilege access. You can see that in our security posture. We have need to know levels of access. And what that means at Oracle is our access delegation team works in a separate tenancy from our XSES support team. That kind of separation of duties is important because you don't want the credentials from the access delegation people to be able to access the targets at the end, right? Because they're not the support team. You don't want the support team to be able to orchestrate the temporary credentials in the true jails because they're not the access control team. So what you see here on the picture is we have ephemeral gateways that we build up that allow this SSH tunnel. We put those in the access delegation tenancy. The XSCS tenancy has to put together that Bastion server because it has the right network connections. And then those connections are put together using the Bastion temporary VCNs so that the enforcement happens with the connection to your VM. We could do the same trick with SSH and XSCC if you run that. It's just now we use an S-tunnel service. So we maintain a separate S-tunnel endpoint for delegate access control from operator access control so that when your team is working, when Oracle asks for access, you can see that the right tunnel comes up. And if the right tunnel didn't come up, you could use that in your security posture to infer that maybe something has gone amiss. You know, we can't make an assertion that software won't fail, and we can't make an assertion that people won't do something wrong. But what we can put in the place is a design that uses the minimum privileges, not just for the people, but task-specific network connections that you can see with your proxies independent of what the OCI IAM system tells you in the OCI audit system. So that the separate tunnels are really clever, and your security team should evaluate the benefit that those separate tunnels have for your auditing as well as your response. When we're working, I'll show you a quick example here of audit log metadata. So this is a HTML interface to the Oracle Linux audit log records. And in this HTML interface, I'm showing you an example of what happens when we access a system. You can see here this unique access request ID. That makes it so it's very easy to index to something that's going on. This request ID here, this is the user. So this, you don't know that this is me because it's obfuscated, just like you don't know that this is me because it's obfuscated, but the software does. And you can see the resource here is a particular VM cluster. You can see the level of privileges that I've asked for, the amount of time. In this case, it was 4 hours. And I did 4 shells. So I shelled in 4 times. I goofed around a little bit, and you could see, I was there for 13 seconds once, 5 minutes, 38 seconds here. And you get an idea of how long I've been working. The audit records are hard to read. So if you've tried to run an AU report, I mean, there are people that know how to do this, but if we want to do it at scale and we want to do it with people that haven't spent a lifetime studying how to use AU report, the Oracle developers who happen to be really good at studying AU report have taken the audit log record, which you can see here in its gory details. You can see a node that's a server that was accessed, proc title, the command that I ran, the argument, copy, etc password to test file, the current working directory. Sometimes you want to know what that is because you got to figure out where things are copied. AUID, that's my audit user ID, the thing that I authenticated to. Effective user ID, there's an EU ID that's in here. In case I've done an SU, you want to find out like how I'm operating. Tying all this together is a little bit hard, but we've built software automation that now gives you a high-level summary. Command I executed was copy etc password to test file from all of this Oracle Linux stuff. The next thing, I edit it, right? So you want to see what happens. I'm going to change a file. The keystroke records, these are TTY entries. You can see here the TTY entry interpreted in a way that you can read it. And so if you've ever looked at a TTY entry, maybe good humans can read it. Software can read it pretty well. You can see here with VI, capital O to open. I type the quick brown fox jumped over the lazy dog. I make these same mistakes every time. My friends laugh at me that I duplicate these backspaces. You can see how I backspaced into this. And of course, VI exit, escape, write, quit, return. So if you want to find out what happened when somebody edited a file, this tells you how they edited the file. If you want to learn from Oracle how they fix the file so that it works, so you don't have to call them next time, you can learn from Oracle. If somebody helping you out makes a change to the system and you forgot what they did or they didn't tell you what they did, the software remembers it and it always tells you for you. So we want to show this as an example of not only are we controlling access, right? We're preventing people from doing things they're not supposed to do unless they're allowed to do something, but we want to remember what everybody did rather than count on people writing stuff down, rather than count on people telling you, updating the ticket. Like someone runs the commands, copies and pastes, puts them back in the ticket. Things can go wrong there. This just does it automatically for you. So something went wrong, you need to open a security incident event, or you're just not sure, right, what happened. Tying the human to the request is done by an API that is accessible by people at Oracle that are authorized to sort out the personal information. So what we could show here for this access request, here was the ticket, here was the reason we did it. This operator list, JT Wright, that ties to this username that we can tie back to that temporary credential. So what we want to make it is when somebody needs to know the person, it's fast and easy. But if somebody doesn't need to know the person, they'd have to gain access to an account that is authorized to do that. A few quick pictures about how we put it together. I'll skim through these in the slides. You'll go to create a subscription. That's a cloud interface. You can see the 4 models there. You will create and assign a control. This is a little bit busy of a screen, but in this screen, maybe you can zoom it in. You'll see that we have Oracle Cloud Infrastructure, Cloud of Customer. It's a VM cluster. You select VM clusters from a pull-down list. You can see a list of a bunch of these that I want to do in a batch process. Once the control is created and assigned, you'll get an access request. If this mechanics of the description here, we're doing a demo, is in the description. We've got a request ID, this OSID, your VM cluster, date, time, severity, the things you need to approve it. If it all makes sense, you can push the approve button. If you need more information, I mean, we as people try to do a great job. We say what we want to do, but it might not be clear. You might need to know more before you let us do something. So you could ask for clarification in a way that the chat history is memorialized with the access request. You might also want to tell us something that's important. This system is still in production. You need to take care. We know this system, the application is sensitive to an ASM disk group rebalance. Don't run an ASM disk group rebalance while you're logged in. Let us know so we can move the application. Or if you're going to do an ASM disk group rebalance, you got to run at ASM power level 1 because the application will not tolerate if you run it at anything higher than power level 1. This helps us work together as humans, just like it helps us work together with the technology. Once you've approved, you could say do it now. You can also say do it on the weekend. You could say do it Tuesday at 9 p.m. Central Time or something like that. This helps us get the scheduling. So when people need to do work, right, they're real people. They have families and jobs and lives and things that they do. To help everybody plan, we can schedule this in the future so that you can get ready, move your applications, do whatever, or you can pick a time. I'm back from lunch at 3 o'clock. I want to be there when you do it. I want to approve this to be 3 o'clock Central Time when I get back from lunch. You could stop it at any time. There's a big red revoke button. When you hit revoke, it terminates the connections. It removes temporary Bastion servers. It removes temporary accounts. It goes inside and uses kill to wipe out all the processes that were started by the temporary user. I mean, this will stop the work. You, of course, have the risk that if you stop the work and it's a jagged edge, you'll be left with a jagged edge. But it might be better to do that. So the decision is yours. Once you've revoked access, the way to get back into the system is the software will require a new access request. If you do revoke for something that bothered you, you should definitely open an SR or security incident to describe why you did it so we as Oracle know what's going on and we can make the right adjustments, whether it's to do an investigation or to reschedule something for a future time. So anyways, with that, Leo, I know we're close to the top of the hour. Any time for questions, comments, or would it be useful just to kind of walk through the interfaces and see how this really works in the last 5 minutes?
Yep, let's do that.
All right. So we are back in the business of live access. So the first thing that I want to show you is what these user interfaces look like. So when we have delegate access control, when you want to create a subscription, the first thing that you do is select create a subscription. When you choose a service provider, that's where these lists of service providers, and this is how you get like Oracle Database Cloud Operations, that's our infrastructure operations team, or Oracle support, create that subscription, and now it allows you to subscribe a VM to that service. Once you've created a subscription, you'll create a delegation control. So you put the delegation control in a particular compartment, you give it a good name, and you can select a subscription. So you might have in your tenancy lots of different things that you're subscribed to. You only need to subscribe to the particular thing that you want. So if you want to get if you're engineered system deployment is infrastructure support, assisted patching, this is where you create that delegation control for that specific subscription. Our resource type, if you want to do Cloud at Customer or Oracle Public Cloud, you can pick in your tenancy, you might have a compartment where you've got some Exadata VM clusters here, and I can show you this 1341. You add that resource, you can build a nice big batch list and then hit go. When you have that resource, you can bring all those resources under control. You might say, for things that are safe, I want to do it fast. I'm in a development environment. I want fast resolution. That could mean as soon as Oracle asks, you want the software to automatically say yes rather than page you in the middle of the night. When you pre-approve, you still get the temporary access, you still get the truth jail, you still get the integrated audit logging, but now the access to the system is done on your behalf rather than you logging in and doing it, and you still get an OCI audit record. So if you need speed and operational efficiency, you pre-approve. If you need control and reduce risk, then you want to have a person approve. And if you click the second approval button, this will require a second approver on the system. So not only does the software require one person who's a different identity to approve, it can require a second and further different identity. This is handy in that the administrator account is one account. If you require a second approval, the administrator is not enough to say yes. So of course, the administrator can make a new account and authenticate to that new account and be the second approver, but at least it helps us prevent mistakes. And it also helps us generate noise, right? You know, when the administrator is making that new account, there's audit records. You might say that during patching, I just want this to be fast. If you auto-approve during patching, it will take the control that you have in place that says the system is locked down now. You always have to say yes until you're in a scheduled patching window. And you could say in the scheduled patching window that you're allowing Oracle to get in right away because you want to fix something fast in a patching window, and you might have already moved off any critical applications. Notifications. So we support OCI topics, notification topics, standard OCI service. You can send the notifications for creating an access request, logging in, deleting, all the lifecycle management. Those notification topics are subscribable to you with email, SMS, HTTPS custom URL. That helps you integrate it into your change management system if you'd like to do that. So in our example, we have, if I want to create an access request, I will do this. So in order for me to log into the system, I have to authenticate with my hardware multi-factor device. I'll try to do it through a cloud interface. So in order for me to authenticate, I will use my USB security key. So this is imagining me operating as the Oracle operator. Can't do the USB security key without a little bit of help on my fingers because it's too dry here in Colorado. I have a delegation control system that I want to access. So one thing about this Oracle database service is VM cluster 1341. This VM cluster has an OSID. If you open a ticket, you'd copy that OSID in the ticket. I'm going to go back to my system. I'm just going to go look for that. So my operator, I look at the system. I can see that delegate access control is enabled. And if I want to go access your system, I can click an access button. When I access the system, I'm going to access the system with a root jail. Maybe I just need virtual machine diagnostics. I will give it a ticket. My 1646 ticket is one that I like to work with. I'm going to test this. Actually, I'm going to do a demo for Ask Tom. Service types, I'm coming in for assisted patching. Severity, this is 4, right? Maybe we don't need to do it right away. And the reason, showing off the tech. When I create my access requests, there will be a notification. That notification comes through all kinds of methods, including email. It takes a second for the email to register, so we'll just do it back here for access request. There's a raised access request. You can see I just made it, Jan 29 at 1901 UTC. We're showing off the tech. You remember that reason that we just typed in there. So from that access request, I can access an interface, interact with the provider. This is where I ask a question. When I approve it, I can give it a message. I can give it a comment if I want. I can approve now or later. Maybe I want to go to my browser time zone and say, gosh, do it at, Friday at 10 o'clock in the morning. Or I can approve it now. When I type approve now, inside of the interfaces on the Oracle side, what I will see is an access request is approved. So if I go to the virtual machine diagnostics that we just had, you can see here, there is an access request that I just created. And then from my Oracle operator, you can see that this cage creation is in progress, meaning my access request is orchestrating the temporary account inside of the true jail, temporary bastion servers. This takes about 5 minutes to do. So it's a little longer we can do in the demo, but I did create one of these slightly earlier today. So I don't have it in this, no, not this one. So I created one slightly earlier today and I did it in a command line. So there's other ways we can integrate this. So if I go to the command line for you people that are doing, into these sort of shells, I can go to internal CLIs that I work with. This is a little bit ugly, but just to show you how the integration can work with APIs. I can ask for the Bastion session. From this Bastion session, I have to authenticate with my YubiKey. And what I can see is the cage has been deployed. And if I want to shell in to this particular server, I run an SSH command that goes through an OCI Bastion with this public endpoint. And so again, this server is deployed somewhere in OCI. When I want to shell into the server with that temporary account, I use my YubiKey. The first step is to authenticate to the Bastion server. The second step is authenticating to the endpoint. You can see I've landed in this Cheroot jail. You can see the host name is this particular server. If I did an SU dash, you'll see that that'll be rejected because I don't have a root password. If I did that trick before, let's see, password to test file, vi test file, quick round box. I can't type, but that's all right. Escape colon right quit. This audit record takes the better part of 30 to 60 seconds to get through the audit system. We can see from the access request, we go back to access request, the one that we approved here, that's the one where we're building the Cheroot jail. The access request that we have here, this is the one that has those audit records. And we'll see if the audit report has come over the last time that we've been working on the system. So you'll see here, it's not generated. Sometimes the software takes a little bit to generate the audit report for you. This is pretty typical with Oracle Linux audit records. You batch up the audit report, you send it every 30 seconds or so. Let's see if we got it. Rather than have you guys waiting for it, that if you wanted to pick up those audit reports from other systems, so we could take an older access request, and from an older access request, we download the audit report. You can see that audit report here just downloaded. And from this, you'll get a nice record of the commands and keystrokes, the different sessions that get open. You can see the times here. These are 30, 60 seconds. you can see the startup shell. So a lot of these commands that are in here are the startup shell, the sudo su, who am I, ping oracle.com, sudo su. So you can see what someone did when they access the system. So anyways, we're 5 minutes over. I'll give it back to you, Leo, and hopefully I gave you guys something that's interesting to use.
Yeah, so let's open the floor for any Q&As before we close the tech talk. I guess there's a question in the chat, like, is it free? Like the Delegate Access Control, is it free? Like, does it comes with their subscription with the database cloud services? Like, can they just use it?
The software is included, the cloud operations support and the database cloud support are all included with your OCPU subscription. The engineered system deployment and infrastructure support, if you were to subscribe to that, you would also need to have written, you would have needed to get an additional SKU for the Oracle services. So you could still subscribe to it. There's no penalty in your tenancy if you subscribe to it, but the staff that would deliver those services would only deliver those services if you bought the SKU that was associated for it. So when you apply delegate access control, that doesn't change your bill. But to get the services, the Oracle support and cloud operations support are included. And then the other ones, if you want Oracle customer success services, those are additional fees.
Okay. Let's check more if there's still any questions. If none, I'll just show them where they can find additional resources. So we're posting the replays of this tech talk and also share some collaterals. So here's the join link for our public Slack workspace. So join our Slack workspace and join the discussion anything about database cloud services. So you can just scan the QR code or just copy the join link. So once you're in the public Slack workspace, so you'll see different channels there. We also have a Gen AI chatbot, Ask Debbie, that's part of the Slack workspace. So it's using a RAG the chatbot using OCI Gen AI Oracle Database 23 AI, and it's also running on Exadata database service. And yeah, we also have Live Labs. So if you visit Live Labs and you just search for Exadata database service, so you'll see all the get started guides and workshops for all the database uh, cloud services. And yeah, so with that, this brings the session of Tech Talk with Leo and Jeff to an end. So until our next session, stay safe and be prosperous. Bye.